All right, 8.5, exponential and logarithmic equations. So this one doesn't really have any new ideas in this lesson, but we're going to be applying some of the ideas, especially in the previous lesson where we learned how to manipulate the logs. So you might look at number one and you might think that's kind of difficult. Oh, my iPad is frozen up. Oh, there it is. But if we use some of our log properties, we're going to be able to solve this pretty easily. So this one would be easiest, I think, and there's different ways you can do it. I'm just going to try to show you the easiest way to me, the way that it looks, the way that it makes sense to me. We can change this into logarithmic form. So this 2 would become the base, right? And we'd end up getting x equals, or let me change to my blue, x equals log base 2 of 243, right? This 2 went into the log base. Let me double check myself really quick. Yeah, now I can just type that into a calculator. So I'm going to type in my my graphing calculator. I'm going to have the log base 2 of 243, and I get 7.9. So we'll say 7.92, and there's our answer. Right? It'll be very beneficial to have a graphing calculator where you can do different bases in it. Right? If you're using just a plain old like TI-30, you're going to have to convert these into base 10 every time. And you could do that. That would be log base 10 of 243 over log base 10 of 2. And you can do that every time, and you can type that in like that. It's just much faster to do it the other way. Right? So moving on, number 2. So again, what I'm going to do is I'm going to start off by putting this into logarithmic form. So this time I have my 2x in the exponent. So I'm going to have 2x equals log base 5 of 20. So x is 1/2 log base 5 of 20. And we could type it in right like that. Or we could, well, you know what, we'll just type it in just like that. We'll say 0.5 times log, and I'm going to find my log base button, 5 of 20, and I get 0.93. Right? And if we were to try to type that back in, we could say, well, 5, we could plug it into this thing here, and I'm going to do that in just a second just to make sure I'm doing it right. 5 times that 0.93, and I press enter, and I got 20 out of it. So you're always welcome to double check your answers. I'm sorry that you're not able to see my calculator, but I'll go over some of this in class, how to type it in. Number 3 here. Oops. Again, we want to start off by converting this into log form. So my exponent will become all on its own. So this will be 2n minus 3 equals log base 15 of 245. And I like to do all of my solving and then type everything in at one time in my calculator. I think that makes it a little bit faster for me for these. So this, I'm going to add my 3 over. So I'll have 2n equals log base 15 of 245 plus 3. And then I'm going to have n equals 1/2. And I like to leave it as a 1/2 whenever I type it in my calculator. Parenthesis log base 15, 245 plus 3. But you have to remember to close that parenthesis at the end there. So I'm going to type in my calculator 0.5 parenthesis. Then I have my log base button, 15, 245, and then plus 3. And you also, whenever you type these in, sometimes your calculator will open a parenthesis here. You want to make sure that you close it. That way your plus 3 is not inside the log, right? And whenever I type that in, I got 2.5. So let me scroll that down a little bit. And n equals 2. We'll say 52. And there we are. Number 4. I'm going to give myself extra room for this one. I feel like I've been cramped there. This one's written as a log, whereas I think all of them so far, yeah, all of them have been written as an exponent. So what we're going to do here is we're going to go the other direction with it. We're going to go from a log to an exponent here. First thing we need to know is what is the base of this log? Well, it's not written, so that means it's an understood 10. It's the common log. So the 10 will come over here and bump the 2 into the exponent. So this will be 3x equals 10 squared. So x is, well, 10 squared is 100 divided by 3. So this would be 33.33, right? It's like 33 repeating. But since we're just rounding to 2, we can just do 0.33. And there we are. Number 5. So we have 8 log base 10 of x equals 16. And I'm going to divide by 8 on both sides to get my log by itself. So I divide by 8 and I get log base 10 of x is, well, 16 over 8 is 2. So whenever I convert to exponential form, I get x is 10 squared, which is 100. Nice and easy. Number 6. Now this one's actually going to need some manipulating before we solve. Trying to get rid of those logs, it wouldn't work really well we can't really get rid of them while they're separate. We need them to be a single log for us to be able to convert to exponential form. So that's what I'm going to do. I'm going to smash them into one log. There's a plus sign here, so that means multiplying. So my new log will be log base 10, right? And I'm going to write that in there, of x plus 21, and then really we have times x, right? Because it's multiplying that whole quantity there, and that's equal to 2. So this would be the same thing. I'm just going to multiply this x. I'm going to distribute it in. So this is log base 10 of x squared plus 21x equals 2. Now I'm going to convert to exponential form. So this will be x squared plus 21x equals, this is going to be 10 squared, so 100. This is a quadratic equation, right, because of the x squared. So I'm going to get everything equal to 0. So x squared plus 21x minus 100 equals 0. I'm going to try to factor this. So I'm going to factor my 100. So this will be, what could multiply to be negative 100 and add up to be positive 21? I'm thinking that 75 and 4. About positive 75, negative 4. So this tells me that x minus 75 is 0, or x minus 4 is 0. Ooh, x plus 75, excuse me. This tells me that x will be negative 75, or x will be 4. Now we need to check our answer here. We need to make sure that both of these make sense. And if you remember back, I think it was in the very first, no, maybe it was the third lesson that we did here, that we talked about logs. Inside the log, like this part here, has to be positive. So that means that negative 75 wouldn't make sense for x. It couldn't be that. We're just going to have x equals 4. All right, there we are. I know that was kind of a longer problem. It was like a couple smaller problems in there. Whenever we got to this step, that was just a quadratic, and that's just review for us, right? But it does make the problem kind of long. Number 7, almost done. Kind of like in the last one, only this one's a little bit easier. We're going to have to combine logs to start off with. So I'm going to combine the log of x minus log of 4, and this will be a log log of x over 4, right? And this is log base 10. Converting to exponential form, I'll have x over 4 is 10 to the negative 1. So x is 4. Well, really that would be like 4 over 10, right? 4 over 10, which would be like 2 over 5, which would be, is that 40%? So that'd be like a 0.4, 0.4. There we are. Number 8. This one's a little bit easier for us. This is like a log base 10. So I'm going to be able to go straight to exponential form. I don't have to do any fancy work before then. So 2x plus 5 is 10 cubed. 10 cubed is 1,000, but that's too big for me to do numbers in my head, so I'm just going to leave it like that, and I'm going to use my calculator for this one. So x will be, I'll have 2x will be 10 cubed minus 5. So x will be 1/2 times the quantity 10 cubed minus 5. So in my calculator, I'll type in 0.5 parenthesis 10 cubed, or you could write it in 1,000, either or, minus 5, and then close your parenthesis, and I got 497.5. So x is 497.5. And just because that's such a huge number, I'm going to type that in just to make sure that that works. So I'm going to type in log 2 times 497.5 plus 5, and I got 3 out of it, so it looks good. You're welcome to check all of your answers. That's probably a good idea to do that. I know that I don't check all my answers whenever I do these, but anytime I get some kind of number that seems a little bit wonky, I normally do that. And if you ever get 2 answers out of it, like what we did with number 6, where you had a quadratic in there, make sure you check your answers there, especially if one of them is a really large negative. A lot of the time, one of those will not work. So these are our problems. These should be very similar to your homework problems. Make sure that you know how to do number 6, because I know there will be some that are similar to this, where you have the quadratic in there, and it kind of makes the problem very long. So let me know if you have any questions on the homework, and goodbye, or good luck.